So what we're going to do is we are importing our environment assets. So I'll just cover this again real quick. So again, just grab one of those planters and just kind of pull it to the edge of your level. Now, of course, if you still haven't been editing it, I want you to kind of extend this first part, just maybe like 5 or 6 blocks. So once this is done importing, I'll show you what I want you to do with the environment. So I already kind of extended it, but the first thing you want to do is you want to grab this end cap, right? And then holding control, it'll let you kind of snap like this, move by increments. So I want you to pull apart this end piece, just a bunch, and then grab one of these middle pieces and make copies of it like this. So just extend this to about, I don't know, I got like 1, 2, 3, 4, 5, 6, 7, or could be 6, 7, 8. So just extend this first part like that. And then what I want you to do is I want you to grab one of these planters and I want you to copy it and bring it to the end. Just copy and paste. I just do Control C, Control V. You could also do Control D as duplicate. That works as well. So then just take this planter and kind of bring it over here, and you'll notice if I pull it into the ground, just pull it into the ground enough for this ground stuff to be under, and then you kind of get this nice ring. And then if you import, so if you haven't yet, right click, import package, environment. So I just did that, but the environment package will give you the water asset that comes with Unity, which is also a pretty cool looking asset. So I'll just wait for everyone to import, but basically this is what I want you to do once you have it imported. So once you have the the environment assets, in standard assets, environment, water, and then just the regular water, not the water 4, prefabs, and then use the water pro daytime and pull it in here, and you'll notice it looks like that. So I'm gonna make it much smaller, just like that. Maybe make this a little bigger.
It automatically turns into a sphere? Or
Yeah, it is a circle to begin with, yeah. And that's my teleporter, okay? For all intents and purposes. We can call this like a checkpoint of some sort. So then, again, while you're still importing and stuff, again, I'll come around and make sure everyone's got the same thing. But also, take a bunch of these props and try to kind of space them out just about kind of how the rest of this is. Because we don't want this to be so naked and empty here. We kind of want to fill it up with these props, just like how they're over here. So just, go ahead and do that. Just kind of have fun with this scene, arrange it. Make sure you got these arrows always pointing that way. So every now and then put some of these arrows that make the player definitely sure where he's going, in case he's wondering. I'm just kind of doing this. Very fun. We're just kind of arranging our little environment. You can also feel free to move these hovering things. I'm actually going to get rid of this one on the top. I don't like it. Yep. Something like that.
Can you walk on those dirt platforms, like the weird giant platforms?
Yeah, you can. These things?
Yeah.
Yeah. You could walk on those too. We're gonna use those later.
Can you talk order thing?
Oh yeah, so if you haven't imported yet, just right click, import, environment. And then it's in the standard assets. And then in there, environment, and then in water, it's right there. And then don't use water 4, but just the regular water. Because water 4 has the waves. We don't want like waves. So just water, and then in prefabs, it's right there, water pro daytime. Yep, so everyone just kind of have fun and start arranging this scene, and you want it to kind of look something like this. It doesn't have to exactly look like this, but the main gist of it being that we want a long corridor, and we want the end of the corridor to have a teleporter or so called.
Pieces in there so you could make the corridor turn and split off.
So this specific light pack, I don't think it has it, but the paid pack of this, I believe it has a lot more like different elements and stuff. Now, there's ways that we could, do split off turns if we wanted to, but for this story, we want to keep it simple, and we don't want too many like confusing turns and stuff. But you'll see kind of what we're gonna do with the next part.
Water is in there.
So I'll see right now which water you got. You want to get rid of the shaded wireframe if you don't want to see those. Shaded wireframe. Yeah.
Is there a way to search? I can
The what? You can't always search here, but if you want to go for the water, what are you looking for?
environment.
Oh, it's in standard assets. That's where you do this.
Which one is it?
The water, regular water, prefabs, and water pro data. Yeah, and shoot, pull that. Oh, sorry, not that way. We're getting this weird black water. Let's see if we can use it like that. Is it people getting the black water thing?
Yeah.
Alright, let me see that. I've never seen that before. That's really cool. Yeah, I see that. I don't know why. okay, you have these scripts you have to download. So you have to delete from, you have these GE comments. And others, go ahead and throw it up. The Sky City Light comes with a bunch of these. Comes with its own standard assets and its editor assets. You just need to delete those. The Sky City Light is kind of an old package. So all of these like effects and stuff, those are all really old Unity scripts. You don't need that. You just need the environment. Delete that and then delete this.
What's this relate to one?
It might be that something's conflicting. And then our camera.
I think there's nothing with properties of water, right?
No. It's something. I believe there's some conflicts.
No, I'm just asking in general.
There is. Yeah, there was a bunch of scripts that were just conflicting with the water, like effects. Like it was using some old Unity effects that was just messing with the new Unity water, basically. Nothing really good. But this is good now that I deleted those things, so yours should be good too.
So,
Yeah.
I originally opened my Dayforce, flip it over.
Yeah.
And then you save this to,
Yeah, so save. So it's already another scene. Yeah. So if you just save scene as, you're saving it as another scene basically. But yeah, your goal stuff and all that stuff is in it's in there. Yeah, in assets. You don't save it somewhere else. Usually your scenes you save them in the Unity package. You just name it. Yeah. And then all your scenes are right here. So you have to do scene A5. I'll show you this one with your goal scene. Yeah, so the water is good now, so you can do that. So it seems to be some conflicting assets. I don't know why everyone for some reason they downloaded this. See if I can do it. Yeah, I don't know what this is. It's GE Common Assets. So I'm just gonna delete these. Delete those. Yeah, delete that. And then in the Sky City Light, you already deleted those. Standard assets. Already. See, it's telling me there's some errors with the utility. I'll delete that. Oh, there it is. Yeah, it was just, for some reason there was some conflicting, but I don't know why it was recording that. It was something to do with me. Because the water is it's just a Unity feature, it should just work right off the bat. It seems like whatever we imported, there was something there that messed it up too. You ever water? No. Yeah, so it's probably had the same thing. Yeah, so see you got a bunch of errors here. So if you just go to, first thing you have to do is the Sky City Light. Just go down to the folder. Just close some of those. Sky City Light, go in there. Standard assets. You wanna delete those from the Sky City because they're like really old assets. They came with it a long time ago. Get rid of that, then get rid of editor there as well. Just give it a second. And then get rid of editor in the Sky City Light. Try to water now. Yep. They make it smaller and just kind of like fit it in there. So again, have a little fun with this. Again, make sure we got these arrows, you know, kind of evenly spread out. I kind of want to make mine even more obvious. So I'm putting them like every 3 guardrails, something like that. You also want to evenly space things out somewhat. Users like consistency, so the more of that you can give them, the more kind of smooth of an experience they'll have. So I kind of have a spacing of 1 here. Here's another one. And then at the end here, I'm actually going to take these arrows and kind of turn them inward like that a little bit, right? So the final arrows, there's definitely no mistaking where you want to go. Just so they point right at this portal of sorts. It's not like, you know, keep going with setting it up, but I'm just going to kind of show you a little bit some of these lighting things, right? So if you're in the lighting window, you'll notice that auto generate is on here. So usually that happens by default. Say if you have that off, and the generated lighting that I have right now, if I clear it, wait a second. And doesn't do it right now. Yeah, so if there's no auto-generated lighting, that's what your scenes look like. So you can obviously, like, this is what people used to do. So the environment light is the light that really makes things look good. See, if there's no environment light, you know, say, you know, it looks dark. So then what you would do is you'd probably look for the light, which is the sun, right here is what it's called, and maybe make the sun brighter or whatever. But then the sun only brightens things to a certain extent, right, from one direction. So what people used to do is you have a sun, and then people would make another light to go in the opposite direction, and they call this like the ambient light or something like that. Like that direction or something like that. And then this one would be a little bit weaker. And then they'd go into the environment light color, and they'd make it something like brighter. And you'd kind of fake it. Like you kind of get to eventually something that might look slightly acceptable. Now again, it still kind of looks wrong, right? You can tell that it still doesn't look that right. But with enough tweaking and stuff, people were able to get it, like, you know, kind of close to a realistic effect. Now I'm going to delete this second light and just show you what happens. So when you have this skybox on, now this doesn't affect it right now because the lighting is not being calculated. So when you have auto generate on here, that's when you actually have the lights being calculated in real time. So if you change the skybox, the ambient light changes as well. So you could keep the auto generate on, or you could just click generate lighting with all these parameters here, and it will kind of take a sec, do its calculations down here in the bottom right. You should be able to see like a blue progress bar, and it'll kind of check, okay, we got like a really light blue sky, you know, we definitely shouldn't have these kind of deep blacks like that. And then you get an effect more like this, and then you can tweak the amount that the sky is actually affecting it. So this is what it means by calculated lighting. So there's a few other settings that you can work with in when you're doing calculated lighting and stuff. Now some of it might not be like readily apparent on kind of like a complex scene like this, but I just kind of want to show you the effects of calculated lighting on like a simple scene. So just kind of as a test, you can go ahead and just make, you know, some cubes and make them kind of like this. Just think of like almost like a starting point somewhere here, and I should move this out of here. So go ahead like this. And if I make a roof too. Now this is just an example. Something like so. And say, let me see here. So right now this is an unlit kind of cube here, for example. If I select these objects and I check off static up here in the top right corner, whenever you make an object static, it basically means it doesn't move. It just like it's kind of a prop. It's like an environment prop. So in order for lighting to be calculated on big objects and stuff, they have to be static. Now I kind of want to show you just an example of what this looks like with no lighting, and then what it can look like with lighting. So in my lighting window, I'm going to check off real-time global illumination, baked global illumination, and what I'm going to do here is just to kind of visualize this for you. Up here in my kind of like preview window, what kind of stuff I'm looking at, I'm actually going to click this baked light map one, and you'll see that it has these little tiles. What these are, this is basically light sampling tiles. So you can see it's very fine. I actually want to make this smaller, so what I'm going to do is here we say light map resolution, 40 texels per unit. A texel is kind of like a unit in like a lighting calculation thing. So 40 texels per unit means like there's 40 of these cubes per like one unity world unit. So I don't want 40, it's way too much. If I make something like 2 or 3, you can see how like there's less of these kind of calculation cubes on each of these surfaces. So it's here where it says texels per unit, light map resolution. See, if you increase that, it kind of increases the precision of lighting calculation, but it will also kind of take longer to bake everything. Sometimes it can take up to like an hour or two to bake like a very complex scene. So just for this demonstration, we're going to put this light map resolution down, and now you can see what that's kind of going to look like here. Now I'm going to go back to the shaded view, and I believe what else are we going to, so then I'm also going to check off ambient occlusion, which is another cool little lighting trick, which basically kind of makes things that are close to each other a little bit darker the closer they are to each other. So something like a corner, like the right edge of the corner will kind of be a little darker in the corner. Here right now we kind of don't have any of that effect. It's a very plain cube. So ambient occlusion, indirect contribution, direct contribution, max distance, a little bit lower, something like that. It's kind of like you play with these numbers till you get, you know, what looks good. But say we got some of these numbers like this. Make sure I got this real-time baked on lighten. Okay, so say I'm happy with all this and I have my cubes static. What I'm going to do is I'm going to click generate lighting. So what it's going to do now, it's going to start rendering. And you can see my Unity here is kind of rendering. Now I'm going to kind of try to see what it's going to do to these cubes. So you can see it already kind of changed the color a little bit. I'm just going to let it do its thing. See like how much of an effect we're actually going to get. So not too much quite yet. Now, I don't know if you can kind of tell, but you can see that it almost kind of has a little bit more light here. So I believe this is because this cube isn't completely in here. But just to make this even more drastic, I'm actually just going to make this kind of like a doorway. Just so you can really see this light, what it does when it kind of tries to creep in during like a lighting calculation. So I'm going to just kind of do something like this, just to kind of show you. Something like that. And let me just see here.
Did you get dizzy doing this?
No, not that much. If you move around too much and kind of mess with it, so I'm still not quite getting the effect that I want. I believe it's because the light is coming from the back. So if I grab my sun, and instead if I turn it, I don't know where it is, oh, it's up here. So if I turn it kind of facing in my door here, kind of just want to show you. So say I have it like this, right? Just kind of creeping in. Light's just kind of creeping in. And if I calculate that now, If I clear it. Let me see here. It was a little bit of a fight to get this looking just right. It's a little bit hard to tell. Well, you can definitely kind of tell with the real time. If the real time isn't on, you notice like kind of like this room gets a little bit dark. Let's see here. But basically, if you had no lighting data, this is what it looks like, right? It's just, it's not very good looking. Like, this is like a classic, like, no lighting that's kind of affected in a room. But if you turn on these real time and the baked, and if you let it generate, you'll start to see that it'll actually try to get proper darkness inside this room, because it's kind of closed off, and some lights will kind of start to bounce off in here and get the proper effect. Say like if I make the sun, the strength of the sun much weaker, see the lighting still hasn't calculated the difference. You see how the shape still stays the same, but this time if I recalculate it, or if I have the auto generate thing, it will kind of recalibrate on the fly as I'm tweaking things. But let me just do this. So there's no sky, none of this. Still not giving me the effect that I want. Well, you know what? I'm actually going to show this on another scene, so you could really see the effects of this. But yeah, you can go ahead and delete those cubes. I just kind of wanted to do a little quick demo there. And you can put this auto generate back on so that it does your light map settings right. My sun, I'm going to make it bright again. And my environment lighting, I'm going to boost it up just a little bit like that. Now, these shadows, you can see that they're kind of pixelated here. since I kind of rotated my sun. So over here, when you click a light in its resolution settings here, you can tweak how high quality the resolution you want to be on the shadows. See, a very low resolution shadow as opposed to like a high resolution shadow. So what I'm actually going to do is I think no shadows looks a little better. It's really kind of a matter of preference. Now on mobile, the shadows can't be that high res. It's just like a mobile phone limitation. So what I'm going to do is I'm going to kind of turn the sun in a way that you can't see these shadows too much.
How are you controlling the amount of the sun?
So the sun is like, if you just click the sun object, there is an intensity here where you can tweak like the amount. So you can tweak the amount of brightness on the sun. It doesn't need to be more than 0.8. And real-time shadows, the strength of them, we can make them just very slight. They don't need to be very, very strong shadows. So there's a few settings here you can kind of play with. And I really want to show this baking lighting thing. Sometimes it doesn't work that well in Unity. It's a little bit tricky to use. But in any case, there's a few different techniques that we could also use to start making the scene look really good. So what we're gonna do next, right? So again, you're probably still kind of arranging your scene here. So let's kind of start with our player, right? So if you already do have a player in there, or FPS player or whatever, you can go ahead and delete that guy. I think I already deleted him from here. And what I'm going to be doing is I'm going to be creating a new camera.
First person character.
Yeah, you can delete it from there. So I'm just going to go to Game Object Camera, and I'm going to create a camera, and I'm going to put it kind of like at the beginning of my scene here. So you go to Game Object Camera. Yeah, so something like this. So now what I'm going to show you is another really cool Unity feature where you can kind of use some of these special effects and post-production lighting to kind of make the scene look even better. So the way that you get that is if you go to the asset store, there's the Unity package that Unity released officially. If you just search post for like post-processing, the first result here, this third one, this first one's fine too, but this third one right here, it's called post-processing stack. So if you click that, this is actually going to allow us to kind of start tweaking the lighting even further and do things like color correction and some other cool features. So go ahead and grab this post-processing stack. So you go to Window, Asset Store, it should be in there. If you ever close any window, you can always pull up a window by going to Window. Yeah, I know, just make a new camera. Don't worry about it. So now let me explain how post-processing works, right? So post-processing is a component that runs on the camera. So the place that you find it, it comes with this folder called post processing. But the way that you actually add it to the camera is you click your camera and you go here to add component, and it'll let you type. You just start typing post, and the first thing that shows up is post processing behavior. So you put that on your camera, and it shows up just like that. Has it's a little component. So then what you have to do is you have to create this special kind of file. It's just like remember how we made an animator controller to control an animation? So what we're going to do is we're going to create something called a post-processing profile to control the colors and the final kind of post configuration of our project. So all you do after you've imported your post-processing stack, you right-click in your project and you create a post-processing profile. It's right there. And you call that something like, I don't know, my post or whatever you want to call it. So it looks like this little Unity icon. And then you grab and you put it in your camera there where it says post-processing behavior and it wants none post-processing profile. You just take that file you just created and you put it in there. So everyone just go ahead and do that, and then I'll show you how to start tweaking these and make your scene look pretty good. So this is the add component on the camera. Scroll down, get that component, and then start typing post. Forget. Yeah, and then just start typing post. There it is. Post processing behavior. And then go to project here, and you want to create something called a post processing profile. So you right click, you create, create. Post processing profile. We call it something whatever you want, and you put that there in the camera. Yes, so you take that, yeah, and you drag it in there. So now you grab the camera, and then you put that file at the bottom there. Scroll down. Yep, and then you want to drag that in there. Yep. Right? Probably we were playing with the exposure on your skybox. Probably it. Kind of like the lighting settings you were kind of playing with. Sometimes we'll take a second. Refresh. Oh, you turn off the light in here. That's why. Yeah, you turn off the light preview. Yeah, and then your sun is probably really bright. Yeah. So nothing too drastic. It's always kind of, yeah. So everyone's got that post-processing profile.
I don't see anything.
So did you import the package?
Yeah.
You got another script error or something. Yeah, that's fine. Always just go to the console and see what error it gives you. And you just double click the error and it'll open up where the problem is. Guess it just is expected, semicolon.
Yeah.
Line 10. Line 10. Yes. Semicolon. And this should be capital. I'm just going to let it file scripts. Yep. Now I should have it. You go to camera, add. Yeah, there it is. And then now it should all be there. Create. There it is. Okay. Just cross it in my post. And then put that in the camera. You put it in the camera? Go across? Okay. It's not. So this is really fun, right? So what you're going to do now is you're going to take this post-processing profile. Just if you click this file, you'll see this whole side kind of opens with a bunch of these settings in here. Now I'm going to kind of go off and just explain what each one is, right? So anti-aliasing is the first one that you'll see. Now enabling anti-aliasing, you might not see it right here, but let me just explain really quick what anti-aliasing is. And you could, if you just Google it, anti-aliasing, you'll see that anti-aliasing is actually the technique used to smooth out edges, right? So a typical computer draws a line like this. An anti-aliased line basically blurs those edges and makes like an edge look smoother. See that? So this is especially important in VR. If you don't have any anti-aliasing, a lot of things will kind of look jaggy and and weird in 3D. Now this is a completely normal way for a computer to draw a curve, because if you think about it, screen is made of pixels, and the only way to make a curve, it can't actually make a curved line like that. It can only make like a staircase kind of on the lower pixel level. So anti-aliasing, what it does basically is it kind of blurs, finds like a common ground color between these, and it basically smooths it out. That's how we have, correct font smoothing. See, that's like a crappy font drawing, and then this is like nicely smoothed font. So it's just a common technique people are already used to kind of seeing in most high quality productions. So yeah, that's what anti-aliasing kind of does. So by enabling that, here you have like a few settings, like very extreme quality and etc. Again, you maybe don't really see the difference, but if you do kind of try to look at it, let me just maximize on play here so you can see it on the projector. So actually no. So just, do you kind of see? I want you to look at. It's fairly noticeable, but if you look at like the edges of objects, you can see how without it, it's kind of like crisp, whereas with it, it kind of blurs those edges a little bit. It's not so much of a noticeable effect maybe on screen like this, but it is a noticeable effect in VR. It kind of just makes things look smoother. So that's anti-aliasing, right? The next one is ambient occlusion. So ambient occlusion is a lot more noticeable. If you click it, you'll notice it's kind of subtle at first, but you'll see how it can actually get more detailed. So you notice that what it does is it kind of adds a few more kind of extra shadows behind things. You see that here? See, there's no shadow with it. With ambient occlusion, it kind of puts shadow there. So if I just increase the intensity, or like the radius, you can see that if I make it high and no downsampling, and if I do the high precision, then you could really kind of see the effect. So you can see what it actually does is it approximates shadows kind of where objects kind of meet. So without it, it's kind of, things look, see like that? It almost doesn't even look that good without it anymore once you've seen it with it. See, with ambient occlusion, everywhere where edges meet, now you notice it's actually just an effect on the camera. That's why when I kind of approach things change. But basically what happens is wherever edges meet or two objects are kind of close to each other, it will kind of draw this shadow. Now you can tweak, if you tweak the radius, oops, where is this? If you tweak the radius, it basically tweaks the distance. So if I make the radius really tiny, you'll notice that it kind of keeps it very localized. It just kind of spreads a little bit. If I make the intensity very strong, you can kind of see the effect a lot more pronounced. See, as the radius is very small, it only kind of captures the edges, and as you increase the radius, it kind of tries to, you know, kind of like that. So there's two ways of using ambient occlusion that work really well. One is with a really small radius and like a decent intensity to kind of really shadow up the edges. Another way is with a really large radius and a small intensity to kind of soften up the shadows on things. It's kind of up to you to find like a sweet spot, whatever kind of looks good for you. Again, we don't want to go too far on the intensity.
Mine doesn't have any effect. Is that because something is not like that?
Did you put it on your camera? Let's see. We still have this guy. This guy. Which was the controller. And with your new camera, you want to have it. So now, because you're running, oh, you got this. Okay. So because you have, I believe, this version of Unity, but it's still here. Yeah, it's still there.
Honestly.
Yeah, so because your version of Unity is a little bit clearer, for the newer version, they update here and here. But in your version, you're only going to be able to see it in the camera. But with the newer version of Unity, it also kind of shows you the preview in here. But yeah, it was because you had the other camera on. So we'll get to these in a second. But yeah, you can see how. So this one, the only ambient in the old version of Unity effects here, but the other ones are only down here. So then you can see how you play them, these settings. So again, if you don't notice, your camera, you probably want to put it like the camera. Wherever that is. Which could be anywhere. So let's go back to where we are. Yeah, well, sometimes it does that depending on the version of Unity. But it should do it on both. But yeah, if it doesn't do it on both, I think also delete this old FPS controller. It's now it should be showing both places. You have two cameras, one with an effect and one without. So now, yeah, now you should be able to see it.
But we're looking at the camera.
So you're looking at the camera. It also the scene updates for some of the things. It seems to do. You have the newer version of Unity, so it's doing it for in both places.
Yeah, it's one of the things that
See that?
I like.
So are you seeing the post? Changing the scene?
Yeah.
Is yours too?
Yeah, I did.
Are you seeing the effect
Yeah.
on the ambient? Very good. So that's that one. Then we're gonna go next. Screen space reflection. What that basically does is it says it only works with the deferred rendering path. It's kind of what we talked about then a little bit. You wanted to do like an accurate reflection on the ground of something. So say like I grab this floor or actually something else. Yeah, I see if I have it, I have to click the camera and the rendering path, you can almost see it right here. It says it, screen space reflection. If I turn it off, it says this effect only works with the deferred rendering path. So deferred rendering is just a different type of calculation that's done in a camera. There's something called forward rendering, and then there's deferred. I don't know the exact difference. I think forward is just like the classical way. It starts with whatever is in most in front, and then it kind of renders just kind of forward. Whereas deferred does it like a different way. I'm not sure exactly what the difference is, but you can see when I have the screen space reflection on, do you see how it's kind of reflecting the barrels and everything kind of slightly? You see that? So in order to get that effect, you should click your camera and switch to deferred. Only then will you be able to use the screen space reflection. And you can see change the amount of blur on it, the amount of intensity. You click the camera, and right here where it says use graphics settings or whatever, there should be deferred. And you can see it's very slight. Now the reason why it's very slight is because it's, you know, the smoothness, metallic is kind of is what it is of this material. But say I grabbed like, you know, like I make another plane, and if I make this plane, this material, like if I make like just a fully reflective material on this plane, so metallic all the way up and smoothness all the way up, you can see what that does, right? So it basically, it creates a mirror. It's kind of it's an effect on the camera, because what it actually does is it just takes a photo of whatever the camera is seeing, and it just kind of inverts it mathematically, not like actually like just kind of flips it like in Photoshop. And you can see here, if you tweak, like, you know, the amount, you see the reflection, blur, step size. There's a few settings you can kind of tweak here to how much quality you want on this. If you go high quality, you can get like a pretty nice reflection. So now again, I wouldn't recommend this for like a full reflection. It works too, but it's always kind of good to just make this this smoothness just a little bit less, so that you can get like just kind of a slight blurry reflection if you ever do go for that effect. So it seems to be even easier to do than all the assets and stuff I was doing then. But yeah, just make sure it has to be deferred rendering for you to do that. And you can see how it can kind of increase the quality of your project, because you can almost see kind of like the reflection of the barrels. And again, this is also a very cool effect in VR as well. It adds some depth to stuff. So you can already see how we're starting to create a pretty photorealistic scene here. It's not like, we're still kind of like bright colors and cartoony and, cartoony sky, but the fact that you're using these types of ambient occlusion shadows, screen space reflection, it really adds a lot of that high quality to a project. Next we got depth of field. So depth of field is a little bit tricky to use, but what depth of field does is, you see that? It uses like an aperture blur. So you kind of have to play with the settings, but what it does is it can blur out the background and keep the foreground not blurred. So something like this.
Why would you want to do that?
So you might not want to. It kind of really depends on the effect that you're going for. But again, it could kind of add a little bit of something to your project. That the things that are really far away are just kind of a little blurred out. It's just another effect that you can go for. That's part of this post-processing stack. So you can see how that looks like. Not the most ideal effect for VR, but it is kind of cool when you walk through stuff and you can kind of see how, maybe this is too strong. So I would make this even less like that, and then you can see like how if you walk through it, you kind of, it's another one of those like filmic effects. Even when you're doing film, when you're kind of recording a subject, you kind of focus on the front and you kind of blur the back, and sometimes you can give that extra professionalism to a certain shot. Maybe you aren't creating an adventure game that tells a story. Maybe you're just showcasing a product or something, and you can kind of make it front and center, and everything around it just slightly blurred. It's also very helpful if your background doesn't look maybe that detailed and stuff. Blurring it out kind of just really makes it cool. And the best part about it is the animations still animate. So if you kind of notice those turning fans, they look pretty cool when it's kind of blurred. You see that? So I mean, it really kind of depends on the effect that you're going for. But in this instance, I'm actually going to turn it off. We don't actually need it. But you can see how it even fixes my sky a little bit. So if you did want it, say like if I wanted it right now, I would make the focus distance something like 5, the aperture something like 0.3, I think would be acceptable. Oh, still not. Maybe like 0.6. That's too little. 0.45. So that's just about right. Kind of like blurs all the way to back, but it still keeps things. Now we can already see that our scene. You see that we got those nice kind of reflections here. We got these nice soft shadows around our objects. So we're already starting to create like kind of like a pretty nice looking AAA quality type scene, and it all really kind of lies in these post-processing effects. Even simple cubes and spheres can look pretty cool when you got like this kind of post-processing. You can see how these spheres, these are just regular spheres that we've been using so far. You can see how much cooler they look when they got a nice little reflection under them and a nice little soft shadow. So even low quality 3D models can be made to look a lot more professional if you use the right camera effects. So next we got motion blur. So motion blur might not be ideal for VR, but I'm just going to show you what it does. Motion blur basically, as the name implies, it kind of blurs the camera a little bit when you're moving fast. So it might be noticeable there. Say if I make still kind of not noticeable. Still not noticeable. So now I don't know if you can kind of tell. Can you kind of tell? How it just, let me just, oh. Let me put my Google VR package in here so I can look around. So, GVR editor, put my camera in here. And then I have to make the camera parented to an object, something like a capsule collider. So I'm just gonna do this. Okay. So make it full screen. Yeah, so that's motion blur. See that? How it kind of like, it almost kind of makes it a little dreamy. Like when you kind of look around, it just blurs the frames. It could be a little dizzying in VR sometimes. So the only time I would use motion blur in VR or something like that, say maybe you're low on health, or like, you know, you kind of want to spook the player a little bit, make them feel like they're like in like a dreamlike state or something like that. It's a nice effect to use. So I'm actually going to turn off motion blur. Next one is eye adaptation. This one's a little bit trickier because you need to be using like a platform that says this effect requires support for compute shaders. So that would probably only be used on Vive or on Oculus or like on the high quality platforms. Eye adaptation, I can just explain what it does because we're doing mobile right now, so we can't use it. It's what the name implies. It adapts to the eye. So when you look at like a bright source, it'll just kind of darken everything slowly. When you look at something really dark, it'll just kind of brighten it up a little bit. So it kind of simulates your retina, your iris, that just kind of like grows when there's not enough light and shrinks when there's too much light. It just, you know, when you walk out into the bright sun and everything's like super bright for like a few seconds and then your eyes kind of adjust. So cameras do the same thing with lenses. Well, when you like pull out a lens into a bright light, all of a sudden it's just over bright, and then the camera lens kind of takes a few seconds. And so that's like a simulated effect in 3D. You could do the same thing. You could use eye adaptation to kind of simulate that effect of the kind of the eye adapting to like a new lighting conditions. But again, that's only usable in for other platforms like Vive and stuff. Bloom is a pretty cool one, and this is a favorite amongst people. So if you turn on Bloom, the way to actually notice it is you want to tweak this threshold. You want it lower. So let me explain what Bloom does, right? So you can see it kind of makes things glow. You can tweak the intensity and stuff. So the reason why when you lower the threshold, the amount of bloom comes up is what Bloom basically does is it checks for the brightest points on a screen. So something like a very white dot on the screen, and it will kind of make a little glow around that. So the lower the threshold, the less bright the point has to be to glow. So if you keep your threshold really high, it will only brighten up like the parts that are really bright. If you lower your threshold, it will kind of make everything really bright. So the best way to use Bloom is a threshold right under 1, like 0.8 or something like that, and like an intensity of 1, something like that. And you kind of just get like a little subtle glow like that. You can tweak the radius or the amount that you want, like this spread, anti-flicker. You really want to. So then what you can also do is you can apply a dirt texture to the bloom. Now, if I just click this right here where it says texture, this little circle to open up this, and if I just search for dirt, it kind of comes with a few lens dirt pictures. So you pick one of these lens dirt pictures, and now if you put your threshold up, you can see that it's using almost like a dirty camera lens. See that? That's what the lens dirt does. Is you can use these different kinds of simulated dirt on your camera to make these glow effects. So it's just another little layer of kind of realism that you can add, is something like, just a slightly dirty camera. And you can really see this effect more pronounced if you look around a little bit more. Like, you can see that. So it's, if you just click there and you just search for dirt, there's just right here, if you just click on bloom, and then right here texture, you just click that little circle to open up the texture browser, and then just search for dirt, and there should be like these 4 lens dirt pictures, and those lens dirt pictures come with the post-processing stack. But yeah, you can really tell the lens dirt when you look at a really bright light source. You can see that how it like kind of has those speckles.
You can do water drop.
You can, yeah, they're kind of like, yeah, pretty much. But it's basically like it simulates like a dirty lens. That's another cool effect. So again, I'm not gonna give it that much bloom. Threshold of like 0.9 is just fine. You don't want to overkill with the bloom. I see a lot of people do that. It can sometimes just make things look way too bright, like dreamy. You notice a lot of the Unreal Engine stuff looks like that. That's why. It's because everything just comes with bloom turned on like right off the bat. So that's kind of the secret to why it all looks so good and dreamy. It's just this. So in Unity you have to go in and just turn all the things on, but you can notice that once you have everything turned on, you're kind of getting pretty close to that Unreal Engine quality pretty much, with the same performance of Unity. It's all just knowing what these shaders are, what these effects are called. It's usually bloom, ambient occlusion. A few of these is what kind of makes that AAA quality at the end of it. You notice it looks really cool like this when you look like in the bright sun. You kind of see this thing turning. You see the ambient occlusion is kind of making these little shadows right around as the fan is turning. And if you play with the bloom, you can kind of see that, you can even get it to bleed a little bit around those fans. Like, it really kind of depends on the effect that you go for. But like a higher bloom, like a lower bloom threshold and like a larger radius. If I look over at that fan now, you can see how it's kind of like, it almost kind of, it's way too much, obviously. But you can see how it bleeds over the fan blades and stuff. So you can, depends on, again, the story that you're trying to tell and, the effect that you're going for. But there's some shots that you can really make, beautiful with using these post-processing effects. If you really want to create like a dreamy, like, beautiful scene and you got like all this light kind of coming in, you could do that. So
can you map all of those shaders to a script? Like activate them in the script?
yep, you could. So let's move on here. Next one, we got color grading. Now, color grading is important because I'm going to explain kind of what happens with color grading here. So when I turn it on, you notice how everything just gets a little grayer. What happens is, without color grading, notice how like there's some points here that are really bright. I mean, like these clouds are brighter than the sun practically. And this shiny metal and stuff is also over bright. I mean, that's perfect white right there. So is the clouds over here. When you turn on color grading, it neutralizes all of the colors, and it's basically called tone mapping. So it finds all the brightest and the darkest colors, and it kind of decreases the contrast between them, making sure that nothing is ever perfectly white bright unless it's like very bright. So you notice how without color grading, look at how much detail I'm losing here. See that? It's just white. You don't even see the clouds anymore. But if you turn on color grading, notice how now it contains the subtleties of the clouds, the slight gray tones stuff. You see that? So color grading is a really important one for achieving photorealistic results. You notice without color grading, it almost looks drastic, kind of cartoony, way too high contrast, right? With color grading, now we kind of have this photorealistic softness on top as kind of like a final touch. There's two types. There's neutral and there's filmic. So filmic, you can see, is a more contrasty. The darker are darker, and the lighter are kind of lighter. You can almost see that these lights kind of start to glow and stuff. Whereas with neutral, we're kind of, just, neutral. It's kind of closer to what real life would actually look like. Whereas filmic, it's if you kind of want to have this, filmic effect. I don't know how else to say it. Kind of. It looks pretty crappy here on the projector. It looks a lot better on my screen, but we're gonna stick with neutral for now. And you can obviously tweak all of these color corrections. So how much white, how much blacks. You can even tweak the exposure at the end of the project. So that's like the final exposure and stuff. You can tweak the temperature, color of the light, cold, cooler or warmer. And you can even, change the hue if you really wanted to get trippy with it. Saturation, make it black and white. So most of it is here in the color grading, and obviously you could tweak certain colors, add more of a certain color or less of a certain color. It's totally up to you. The next is LUT. Usually you have to use a LUT texture. I'm not too familiar with how to make a LUT texture. I'm sure there's guides, but basically I believe what LUT does is it kind of replaces a certain color with another color. So like, I've seen people use like LUT to create like an autumn feel where all the greens are kind of like orangey and stuff like that. So but there's no LUT textures here that you can really do anything with. So I'm not even gonna a neutral LUT. I guess it doesn't really do anything. I barely see the difference. Yeah. Chromatic aberration is an interesting effect. So if you turn that on and you turn the intensity, you can see what it does. Basically, it grabs the edges of the camera and it almost kind of warps it like that a little bit. So chromatic aberration is an interesting effect to get kind of like this tunnel vision a little bit, it works pretty decently in VR because you're always kind of looking forward anyway. So it just gives it a little more dreaminess, kind of tunnel vision slight effect. We don't need it, but it's there if you want it. Grain is pretty self-explanatory. You can add film grain, and the film grain is actually kind of a little animated. So you can see that when I have film grain on, you can see that it's a little grainy. So that's also a pretty cool effect. It's actually a cheap effect, but it's an interesting way to make something look kind of like an old movie, something like that. So say if I go into my color correction, color grading, and I turn the saturation down, and I turn the grain up, I kind of get this, right, like this old school black and white movie effect or whatever. Kind of, you
Is it making the screen shutter like that also?
it's the grain is kind of, it's animated a little bit. What do you mean shutter?
I don't know, it makes it look, it
Like
also
it was
looks
like
like
an old
it's,
film kind of.
Yeah, that's what grain does. The grain literally kind of just makes these little pieces of grain. You can see they're just kind of like doing that. So that's another effect that you can do. But again, for this demo, we're gonna put the saturation up because we have beautiful colors here anyway. And you know, you can change the size of the grainlets. You know, very big is obviously not very great. And it could be colored grain or black and white grain. Vignette, what it does is it basically just kind of makes the edges of the screen a little darker. It's another way of just making your user very focused on the center. So that's what Vignette does. So you can do something like that if you really wanted to. You know, like someone waking up from a dream, like, what? And like, okay. So we don't need that, but it's another cool effect. Dithering, nothing to configure. I forget what dithering does. It's another like animation, kind of like smoother or something like that. But now you can kind of see like how you can take an average scene and kind of start tweaking it and get it to look exactly how you want it to look. Now this works really great with the music video thing that you made, the physics thing, or anything else that you're going to make in Unity. You're probably going to be using this post-processing thing, or you should be if you're not. The older versions of Unity required you to have Unity Pro, so you have to pay for Unity to have this. As you can see, you don't anymore. It's free. So it's very cool stuff that just kind of like is there for you. And that's what really gives the final kind of AAA quality effect to your scene. I think I'm a little bit over ODing it on the bloom here. So let me see here. So we did some basics of level design, you know, how to make beautiful environments, assets as building blocks. So again, I just want to kind of reiterate that these assets that are separated and like individualized are good. They're building blocks. Think of them as like your Lego blocks that you're gonna kind of assemble your scenes out of. You could always combine multiple asset packs to make one detailed scene. We went into sky and sun. These are the special effects that I'm talking about. Kind of like, you know, we already did like some particle systems before, but this is really those camera effects that you want to do. So yeah, the final thing that we're gonna do is, you know, a little bit of scripting for this final part. Is we're gonna get this player to walk through this corridor and to arrive at this endpoint here. So in the meantime, though, you know, the player will also kind of have some visual cues. There will be like we said, like a story. Something will kind of happen. So to just kind of set this up, here's what we're gonna do, right? So we're gonna go to Game Object, 3D Object, and we're gonna create a 3D text. We're gonna create a 3D text. It looks something like this. It'll be very low quality. So if you remember how to make this better, so we're gonna turn it so it's facing us. And to make it more high quality, so it's not so like, you know, pixelated, you go to font size, you make it something bigger, like 48, and character size, you make it something smaller, like 0.5, something like that, even smaller. I made it like 0.3. And what I'm gonna do here is, like, as a first message, I'm gonna write something like "Welcome to Sky City." Make it even smaller, like 0.2. So it'll be just right here. Okay, so Once you have that, I want you to also rename this text. So it's not just new text, just rename it to welcome or something like that, something appropriate. Then the next thing that we're going to do is we're going to take our camera. So if you haven't done this yet, create a capsule like I did and just put it as the body of your player, basically, like that, and then pull the camera into the capsule. If you want the capsule to be right on top of the camera, you can always pull the capsule into the camera and then make its position 0, 0, 0. And then just make sure you turn off this mesh renderer, because we just want the capsule collider. And then once it's zeroed out in there, then you can pull it out of there and just like make it like the body of the player, technically. Just go ahead and do that. Then, again, this capsule, rename it to player, just so it's, you know, it is what it is. It's a player.
So after you put the camera inside the capsule, do you zero it out also?
No, you don't have to. I mean, if just make sure that it's kind of like this. If you just can't see it, you know, safe bet would be to zero it out. But the Google VR, what it does is it already zeroes it out onto its parent object anyway. So you'll notice if I just press play here, you see how the camera will go from the top, it'll just go right in the middle. So it'll always find the middle of its parent object, the Google VR. It's just what it does. That's why we have to make a parent object for the camera, so our camera doesn't like disappear to like the 0 position in the world. So yeah, everyone just kind of create, we've kind of done this before too, just create like a player capsule, name it player, and remove the mesh renderer.
Is there, you want to put it
Yeah, you could pull the camera in. So actually we'll take the capsule, that player, put it in the camera first, then zero it out. And now pull the player out of the camera and put the camera in the player. Yeah, that's good. You get that?
I lost my camera.
Well, where do you have it?
Is there a way to turn the games?
Yeah, I'm not really sure where I wrote it. Yeah, we can just. Create one here. And if you don't want your computer to just kind of be like super heating, it's got so many graphics there.
Is that why we keep?
Oh yeah, totally. You could just, you know, turn off some of the heavier ones like collection, anti-aliasing, ring. should be running. So yeah, but it's usually too many camera effects and stuff, so it'll take a little bit of a toll on the graphics. Oh, yeah, and then we do Google VR thing, so put that Google VR prefab in there. We got their player object ready. Got it? Yeah, just name it player. Yeah, name it. So now we want our player to be able to move through the world. I'm gonna wait for him to come back. Basically, we want our player to move through the world, and we also want him to be affected by the world. Like we want him to bounce off walls and just be able to walk around and not fall off this guardrail and all that stuff. So our player will have physics. So what we're going to do is we're going to grab our player that has the capsule and we're going to add a rigid body to it. So we're just going to make it have physics. So grab the player, add component, rigid body. Then, this is kind of funny, but I'll just show you. If I press play, what you'll notice is the capsule will fall, and sometimes these capsules aren't very cooperative, so they'll do that. They'll fall over, which is definitely you don't want that to ever happen in VR because you will puke instantly. So to make sure that never happens with your rigid body, you can go to constraints here and you can freeze the rotation, and then it'll never do that. So yeah, just go ahead and make a rigid body on the player and freeze its rotation. When you go to constraints, so freeze rotation is in constraints. Yep.
Yeah, I didn't read my opinion already.
Yeah, but it's still it might happen. Just to be sure. Yep. Capsules used to just kind of fall over because they're kind of more like an egg. An egg doesn't really stay up. I guess the new capsule in Unity just stays up right off the bat, but it used to just straight up just fall over.
Why not use a cube or something?
I don't know. I feel like capsule just kind of looks like a body. I don't know. It is a preference thing. Honestly, you could use a cube. It's just better because it's rounded, so it'll go off edges kind of smoother. It'll kind of it's good to have a rounded collider on a player because then he doesn't really get stuck in corners and stuff. That's kind of the thinking, I think. So
Why capsule at all instead of an avatar? Instead of a person?
Well, because you're going to be this person, you're going to be in it, so you're not really going to have a body like most VR experiences. It's hard to make an avatar on yourself move like yourself. There's ways. I've done it in certain projects, but for this instance we're just keeping it very simple. We have maybe about an hour left and we're just going to kind of make this player just walk across. So you'll see, it's just kind of like a floating head kind of scenario, but you're the player. Yep. So now we need to write a little simple script to actually take an input from once you press something and then move forward. So we're going to create a new script. So create C# script, and let's call this one VR player. No spaces. You open the script. And I'm going to zoom this in so everyone can see. Yeah, so here's what we're going to write. So make a few spaces here and do this. So it's going to be if input get mouse button 0. So what we're doing here, and then you're gonna close the parentheses for the first one, close the parentheses for the if, open a curly bracket, few spaces, and close the curly bracket. So our primary mode of movement will be just by touch, just by left click in this instance. So what we're going to do is when a player is holding the screen, he's moving forward. So it's the simplest method to create movement in VR. It's the players, wherever the player's head is going to be facing, that's kind of how we're going to do it. As long as you're holding, you're moving in that direction. So it's going to be very simple. The shooting, which we're going to be doing tomorrow, is just going to work on hover. So it's going to be gaze based, which is another really important way to interact in VR. So as soon as you gaze at an enemy and he's in your center field, you're just going to like shoot him. So, but the click, the actual touch, is going to move you. So that's going to be the primary mode of interaction, is moving like that. So if input get mouse button 0, so that's for left mouse button or for the first touch, open curly bracket, close curly bracket, and what we're going to do in here, so what we could do is, do get component rigid body, but we're not going to do it on update, because then what we're going to be doing is we're going to be pulling the rigid body component on update each frame. So it's not the most efficient way to do it. So I'm going to define the rigid body on start. So up here above start, you're just going to type rigid body, like whatever you want to call it, like rigid, or just this is like a temporary kind of like placeholder for the rigid body. And then on start, we're going to say rigid is equal to get component rigid body, just like this. So make sure it's capital R, all that. So now instead of always typing get component rigid body, then do something to that rigid body, now I can just type rigid and it'll know what I'm talking about, because I did this get component once on start. I don't need to do this once every frame. Does that make sense? Why? It would still work, but it's just a simpler way and it's a faster way to do it. So you don't have to get this component all the time. You just get it once on start, and now you can just say rigid something. So here's what we're going to do, right? So if input get mouse button 0, then in here you're going to say rigid dot velocity is equal to, and then remember this script that we did before, camera dot main dot transform forward times something like, I don't know, 5f, speed of 5, something like that. So now this is kind of important. So camera.main, what this basically does is it automatically pulls the main camera in your scene. Usually when you start a new scene, Unity creates a main camera automatically. Since remember how what we did though is we kind of deleted a camera and we added a new camera. When you click your camera and over here in tag, see it's untagged, there's a main camera tag. So that just comes default with Unity. So make sure your camera is tagged as main camera, and by doing this you're basically making a shortcut in script for this camera.main thing, so it knows what the main camera is. Another way of doing this is you could just define it over here, public camera, my cam, and then what you could do is you could grab over here on player and then pull the camera in there, just like how we did all the other public stuff. But camera.main is like a quick way of just referencing the main camera in the scene. And what defines what a main camera, you don't need this public my cam, this is just an example. What defines the main camera is this tag. So the camera has to have this main camera tag. And then you can just reference that camera just by saying camera.main. And then it knows you're talking about this camera. So now this 5F too, we could also, you know, put like a public float speed equals 5F here, so that we could change the speed later from the editor, just like how we did before in the earlier versions. And then here I don't have to do times 5F, I could just do times speed. You know, it's optional, you don't have to do it like this, but it's, you'll see how then later you could just tweak the speed of the player to anything you want. So that's pretty much it. It'll basically take the forward direction of the camera, meaning whatever our head is. Remember in Google VR, when you turn your head, the camera turns with it. So you want the forward facing direction of your head, and that's what our velocity is going to be for a rigid body basically. So now I'm going to explain a few things here. So just by saving that, and if I go to the player and I pull my new VR player script onto my player, I see the speed of 5 is there. Now if I go around here and I hold left click, I'm doing this. So I'm walking around. There is a problem because I can actually fly up as well. Because remember, our script, we basically told it, you know, whatever facing direction of the camera, go that way. And if I let go, it'll just kind of fall. So I'll show you how to limit the ability to go up in the air. So yeah, just I'm gonna come around. Make sure you tag your camera as main. You also might want to take off a few of the shaders. It seems like yours is also kind of light a little bit. So just go ahead and take off like you're doing again. Screen space reflection, probably kill it a lot. Color grading. Anti-Aliasing. You can do, I mean, color grading is fine. Ambient is fine. I know that one should work. Click. Yeah. Guess hold Alt. Okay, so you also have to put the Google VR in. Yeah. Do you remember how to do that? So you go to Google VR folder, and in prefabs, you want to pull that into the scene, and then you want to put the camera into that one here. You want to put your camera. Yeah, so see what it says, unexpected symbol in the file. So you just double click on that arrow and it'll take you there. Basically, probably like something like that. Oh yeah, so you open the curly bracket here, you have to press enter after this, and close another curly bracket. Open that, close that, open that, close that. Now it's good. See? Because it was like, it was missing one of them. So make sure you always, like, whenever you open a curly bracket, you kind of keep track of them and always close it. Let me see if you can do the alt to look around thing. Yeah, so to do that, you need to print Google VR. Google VR prefabs, and put this GVR editor, and see once the camera, just like how we did before. You want to put basically, that's the Google VR object, and you want to take your camera and put it in this object.
Go around and down to your timeline. And then reset the position of your right. So it's looking right.
What?
And then
You just had it selected.
yeah.
You just had it.
Use the alt. Yeah, there you go.
But you see, it goes up into this guy. So that's obviously not like a good game because you can probably fall off very easily. So I'm going to show you how we're going to do that next. How we're going to put it. So is everyone able to move?
Can't do. No, let's see. Better.
Oh, you have to do it in. Yeah. So see, whenever you get an error, just double click on the error, and it'll take you to the point. So you have. You put the script onto the. Oh, I think you put the player, VR player, you put it onto the camera.
Oh.
You gotta put it on the player.
Oh, whoops.
Put it on this guy. You don't need to put this in anywhere, but
So now try.
you might want to disable some of the post-processing if you want to to run smoother. This is probably too many effects, so that's being a little heavy. Maybe turn off the screen space reflection. It's the only one that really does it. And then you can do the ambient occlusion. Yeah. So try now. Should go a lot smoother. Yeah, you can see how much better it is. The screen space reflection is really the one that does it. And you see you can fall off, so that's not the ideal. Is your so let's see, did you put this layer
Made on top of
the script onto the wait, so your problem here is that your camera, your player is in the camera. You want the camera in the player. And now it should
Also, I couldn't find
yeah.
I can't look around.
Oh yeah, you should be able to do it. Yeah, let me see. Google VR? Yeah. Prefab? Yeah. And then anywhere, yeah. And then just put the camera in there. Yeah, right there. You see it? That's where it wants the camera. So now pull this camera out. In there. And now you should be able to look around the alt. And also on the phone. Give it an arm? Okay. See you tomorrow. Nice.
These look pretty good, right?
So now let's fix this flying issue, right? So again, Unity only does what you tell it to do. And what we basically told it to do was, go at the velocity of wherever the camera is looking, including up. So now can anyone guess how we would limit the up speed?
Gravity?
Gravity is one way, but we still want to use gravity in case there's falling or whatnot. So we want to make the y 0, basically. So we're fine with moving an x and z, but since y is up, we want to make sure that that is 0. So here's how we're going to do it, right? So we're going to create a new vector 3. So here's what we're going to do. We're going to do vector 3, like, player speed or something like that, is equal to, and then just copy this whole part over here. Camera main, transform forward, dot speed, or whatever. Just like that. And then player speed dot y is equal to 0.
and then rigid velocity is equal to player speed, which is basically this. So we're storing this with all its stuff, with all the directions, and then we're just making its y coefficient 0, meaning that all the speed that we have in y is going to be 0. And then rigid.velocity is equal to this new value that we have with the stripped y. Right? So it's basically the same thing we had before, except this time we're storing it in a temporary vector 3, and then we're changing the y value of that vector 3 to 0. And that's what's going to basically stop us from moving in y. It's going to stop us from going up. Still going to let us slide along forward and sideways, but not up. Problem with this is that the player also will not fall, because a speed of 0 and y basically means you're just going to be there, even if you're falling. So a way to make sure that the fall speed still stays what it originally was, instead of making player speed dot y equal to 0, you make the player speed equal to its own velocity dot y. So the rigid body already had a velocity to begin with. If it's falling, we don't want to make it 0, we just want to make it what it originally was. So now what this looks like, I don't have a whiteboard here right now. Picture this. Yeah, it's fine. Picture this kind of like, now we have our, if you see this as a x, y, z, we have our x, screw it. You go like this, you have our new x, oh god, new x speed, and then you have your original y speed and the new z speed. So that's what this looks like. And you're assigning that back to the velocity. So now, with this new code, if I press play, I can go left to right, in and out, but I can't go up. See that? As it should be. So now I can't fall off this level now, which is how you want your level design to be. You need to have a level design that the player can't, fall off or whatever. You want him to continue the story. You want him to go from point A to point B.
You can't fall off for what reason? I thought if you keep it to 0, then
No, I mean, like, since you can't fly up anymore, you can't fly over the ledge, is what I'm saying. So now your player can walk around this area that we created for him. Before, when we weren't limiting the y speed, you were able to just kind of fly up and just kind of go to the side and just fall over.
you said if we make it 0, then it'll limit on going up, and
Yeah.
you can't fall. So we created a
Well, I mean, fall as in fall, but in essence, you can't go over the ledge, is what I'm saying now, because it's blocking you. See that? You can't. There's no way. This level is literally created. It has no holes in it.
If you were to, you'd fall, right? Can you just run up?
Yeah, you would just fall. If there was an opening here, say over here, if I just pull this part, and if I walk myself all the way over there, you will fall. Whereas before, it wouldn't have. It would have just stayed in the air. So that's what I mean by it will fall if there is a falling area. So see, I go here, and there I go. I'm gone. So you don't want that to happen in your game, usually.
So you detected that by making the rigid dot velocity dot y?
making it not change to the camera's up direction. So if you're looking up, it doesn't care that you're looking up. It still won't make your speed any more in up.
I'm just trying to understand what's the difference between 0.
Okay, here's the difference between 0. If I make this 0 and this is here, it won't fall because since the y speed is always 0. Oops, Jesus. Since the y speed is always 0, then they can't go down either. Can't go up, can't go down.
Okay.
As long as I'm holding. But if I stop holding, then that 0 is no longer 0. So see, I'll be holding, and see, see that? But the moment I let go, I fall.
Repeat that.
it'll stay 0. Basically, it makes the speed of y 0. So that's why we have to make it like this. That's the way to do it. So that's basically like a player right there. So, you know, we got a player. Our player can kind of walk around our level. The only other thing that I kind of want to do.
See that code again?
Oh yeah, sure.
I got slides.
Yeah, mine was fine.
Make sure it's like this. So, yeah, got it? Alright. So the next part that we want to do, so now we got, you know, our player moving and stuff. Now I want to really kind of do this story part of the last 30 minutes that we have here. First, before we do that, just grab this end part real quick, this teleporter, and turn off its mesh collider. Because my player kept getting kind of blocked. He couldn't actually walk into it. I want him to actually be able to walk into it. Just real quick. And then, what I want to do here, so it's welcome to Sky City, right? So, what I want to do is, I want this text to be invisible on start. And when the player approaches the text, I want it to fade in. And when the player leaves, it fades out. So just a simple kind of like checkpoint. Hey, here's storyline. So what we're going to do is we're going to create a trigger, just like how we created triggers earlier. This time the trigger will basically trigger the text to appear and trigger it to disappear once you're done with it. So here's what we're going to do, right? So create a sphere. So go to game object, 3D object, sphere, just like that, and make it big. Make it like big, like just the size of the text or something like that. And push it into the ground. We kind of want it to be a hemisphere, like this, something like that. Put it before the text, so kind of like make sure that the text is kind of like at the end of the sphere, because the moment our player will enter this trigger, I want the sky to appear, so I kind of the text to appear. So I kind of wanted something like this. So once you have the sphere, turn off the mesh renderer, because all we need is this sphere collider. You want it just like that. And rename the sphere to trigger story or something like that. This is an appropriate name. Take that text, that welcome text, and put it inside the trigger story, just so they become one object. And you're gonna see how we're gonna tweak this object and create it a reusable story piece that you can just keep changing the text at different points in the game. Something like that, and turn off the mesh renderer. Make sure you check is trigger once you do that. Just make it a lot bigger. The sphere very much bigger. So think of it like the trigger area for the text. Oh yeah, no, not the whole thing. You wanna do that. You wanna, because now you put the text in. Yeah, you wanna take it out and then you're gonna make it bigger. Make the sphere a trigger. Yes, make it bigger. Look at it from don't scale it like that. I just want you to look at it from the side, just so I can see where it is. Yeah, go again. Yeah, and then just go. See it. Yeah, so we want like this text a little bit later. So we want this sphere. Yeah, right before it. That. So when you enter it, the text is really visible. Then just take the text and put it in there, and then make this a trigger. So now next thing we're gonna do is we're gonna write a little script for that. You got that?
Yeah.
The trigger. Yeah, make sure you put it. So let me look at it from the side. Make sure it's So you want it like you want this text. So you want this sphere like you want the text after the sphere. Because you want the player to actually enter the sphere and kind of like see the text very clearly. So you see we need it also a little bit bigger. And if you want to make the text look better, you make the font size something much bigger, like 48, and then the character size something smaller, like 0.2. Now see it's much sharper.
Yeah.
So it's usually you just tweak the font size, make it bigger. Like that. Probably want the sphere even bigger. So we want to make sure that this player can't go around it.
What's the trigger?
The sphere itself is a trigger.
Oh, that's gonna be stupid.
Yep. See, this is text. To save your scene right now, just don't lose it. You got it. Okay. So now this script is fun and very reusable. So we're going to create a new script, C#, and we're going to call it trigger story. So open up your script. Now the first thing that we want to do is we want to define our 3D text. Just like how when we were working with score, remember? Like the script, again, it doesn't know what a story is, it doesn't know what trigger story is. You need to tell it like, what object am I referring to as this text? So, you know, a quick way to know what this is called, if you click it, you see it's a text mesh type. So that's what the text is actually shown as. So what you do here is you do public text mesh. You know, my story or something like that. Something like that. So on start, remember, we want this text to be invisible. So we want the color of it to be completely transparent. And then when we enter it, the trigger, we want it to fade in. And then once we're done with that trigger and we leave it, we want it to fade out. So that's what we got to write right now. So here's how we do that, right? So on start, this text mesh, we do my story dot color. I believe you could just change the alpha dot A is equal to 0. Let me just see if that's going to give me an error. Yep. So you can't consider storing in a temporary variable. So it basically means you can't just do dot .a of something and change it. You have to create a new color. So you have to go color, you know, my color is equal to new color. And then in there, you know, we got like a color of 1, 1, 1, and then 0. Something like that. Make sure you put the F's in here. 1F, 1F, 1F. So, and then semicolon. So what this does is it basically creates a white color that's completely transparent. So the fourth, so this is RGB, so red, green, and blue. To create color white, it's all maximum, so 1. And then the last one is 0 for alpha. So that means like the transparency, it's gonna be 0. So you created this new color, and then you do myStory.color is equal to myColor. And that should make it transparent on start. So I'm gonna leave that up for a sec. Got that? So now if I press play, you know, this should just disappear like on start. So shouldn't be there. It's still there. Oh yeah. The reason is because we got to put the script on our trigger story. So go to trigger story, put the new script you just wrote, trigger story, onto the object. And then right there where it wants my story, it wants the text mesh, pull that text that's inside the trigger in there. So it knows which text we're talking about. So again, put the trigger story script onto your trigger story object. And then right there when it asks you for the empty field, just put that new text that you created in there. But, and then it should disappear. Yep. Good. And then pull the text that's inside of it. Oh, you have to pull that text in there. No.
Oh, yeah.
Yeah. Now if you press play, it should just disappear right after that.
Trigger story inside the suite.
So you have to see it in there an error. So if you just go back there, just double click it. I'll pull out the script again. Sorry, I took it down so quick. So just copy it. So yeah, so you can't do it like this. So you already got that. Then you do myStory.color is equal to myColor, not .a anymore.
Oh.
Yeah. Save that. It won't disappear yet because it still needs to update. We need to put the text in there. So I'll press play. The other thing that you have to do is you do that. So go back to the editor here. And then make, you already did this again. Here. Yeah. And then see there it wants the text mesh now. So grab that text in there. So don't click it, just grab it. Yeah. And now it'll disappear. So now it knows which thing you're making a transparent.
For some reason I'm not getting a public
We'll go back to that. That's what I already saw red line. Yeah, so this, you gotta put a semicolon right there. Yep. And now you gotta go back to the editor. Don't press play yet. Just go back to the Unity editor. And then just go pull that text in there. Just give it a sec to compile. Yep. And now you should be able to pull that block in there. Yeah, and now it'll disappear. So now what we gotta do, and just bear with me, it might go like 10 minutes over or something. Just want to make sure you all get this part. So now what we want to do is, this is a simple timer function. So it'll take like 1 second to fade up. It's just like a very simple fade function. But before we start fading, we need to detect when something has entered our trigger. So what we're going to do void
on trigger enter, just like this. Void on trigger enter. Collider other object. It doesn't have to be other object. This could be named anything you want. You know, my object or whatever. It doesn't matter. So on trigger enter. Collider my object. And then what we're gonna do is right before this, we're going to create a type of bool. So bool fading in is equal to false, like that. So right up here. So what this basically is like a little helper variable for us. A bool again is either a true or a false in programming. So at the moment fading in is false. So what we're gonna do is on trigger enter, fading in is gonna be true, and then on update we're gonna check if fading in is true, then we're gonna do the fading in. So on trigger enter, so make sure you have this bool fading in equals to false up here right under my story. And then on trigger enter, here you do fading in is equal to true. So now that something's entered our trigger, now we're fading in is true. And now we got to check for this on update. So every frame we're checking if fading is true. So here's what we do, right? In update, you do if fading in. Now, there's two ways to check if something is true. You can either do like this, if fading in is true, or even if you just type like this, if fading in, this kind of implies that if it's true. So it's like if fading in, it already kind of is like if fading in is true. It's just like kind of like a shorter way to do it. But just for all intents and purposes, I'm gonna do if fading in and then double equals true. You know, remember the double equals is whenever you're comparing. So when you're doing if something is equal to something, you do these double equals. So if fading in is equal to true, close parentheses, open curly bracket, make a few spaces, close the curly bracket, and then here's where the magic will happen. So now, what's the best way to do this? So there's a few ways to do this. So what we're going to do is we're also going to let me see here. We're going to store the time. So right under bool fading in here equals to false. You're going to make another line, and you're going to do float, and you're going to call this current time is equal to 0. So we're just going to make one float that's just going to count the time. And then over here, if fading in equals true, we're going to do current time plus equals to time delta time. Now remember what this is? This is basically the amount of milliseconds of time that each frame your computer takes to calculate. So what this basically does is this basically going to increment per seconds. So like after 1 second, current time is going to be 1. After 2 seconds, current time is going to be 2. So and the last thing, well, 2 more things, but then you create another one of these colors. So color, my color, you can actually literally copy this from up here. So color, my color is equal to new color. The last thing though is instead of the 0 here, you're going to put current time in there. So that's the alpha channel, which is going to increase based on time. And then the last part, you do my story.color is equal to my color. So you're setting that new color
that's fading in based on time, and you're setting it to the text color. So I'm gonna leave that up for a minute, and then I'm gonna show you what this looks like. But it should work right now. If you just walk into the trigger, you should see it fade in. Okay, so let's try that. So it starts nothing. Walk in. Okay. Oh, oops. I forgot to make mine a trigger. Yeah, make sure your sphere collider is a trigger. And I'm gonna walk in, and there it is. Welcome to Sky City. Just as I walk into the sphere. Is everyone getting that? Yep. Error? Double click the error.
The player needs to play a trigger, I mean, a glider needs to be triggered.
The sphere collider, not the player. Player is a rigid body. Yeah, you probably have a really racket if you forgot it. Double click it.
Yeah.
Yeah, the error. Now I'll open it up. Yes, let's see here. So you have, yeah, you need another, after fading in there, you need to close it. Does it work? Good. So is your trigger story? Yeah, pull the text into the trigger story too, just one option. And then just open the trigger story and make sure the sphere collider is on and that it's a trigger. And now it should work. There. So see, it kind of happens really fast, so maybe you want to move the text a little bit further. But okay, so now check it out, right? So is it working? Let me see. But you have to make it, so go back, sphere collider, make sure it's on. And open it. Make sure it's a trigger. And now you can go through it and it will fire that event in your script. Yes, now you can press play. Try that. So, again, I hope you don't mind that we might, go over a few minutes. But this is a really fun part of the lesson. So, the other thing that we want to do here, and that we can do, is we can play some narration. So we can actually play some sound that says, "Welcome to Sky City." I have a method that I like to rip my sounds. Now, again, just like how I was doing the Photoshop thing earlier, I don't expect you to go and rip the sound right now. I'll just rip it for you and create the sound. So I like to use this thing called SitePal. It's called SitePal. You go to their demo lounge and you grab, this right here. Actually, I think I need to be using something that has Flash. So SitePal. Okay. So what you could do is you could tell her, welcome to Sky City. Oh. Wait. I don't want the translator. Sorry. I want the multilingual text-to-speech. Yeah, so what you do is basically, again, I'm still in Chrome again. There it is. So you tell her some text like, welcome to Sky City. It should be like,
welcome to Sky City.
and the text, it's pretty good. I kind of like it.
Welcome to Sky City.
That one's kind of robotic.
Australia.
Welcome to Sky City.
Yeah, it's alright. So, what I do here is, I'm going to have to stop the screen recording just for a sec. But basically, what happens is, so I'm going to stop it right here, and I'll restart it.